Good afternoon, everyone. I hope you all are doing well and working hard. So, welcome to my channel. In previous video, I have discussed the concept of linear search, and in this video, we are going to learn the concept of binary search. So, let me recap first that what is searching. Searching means getting a particular element on a specific index. So, as in linear search, we have noticed that linear search works in a linear form. That is, you have to search in a sequential form. Okay, you are starting from the index 0 and searching it till the last index of an array. All right, but in binary search we have a different concept. Okay, first of all, for binary search there is a condition that your array should be sorted. All right, it means you can only apply binary search if your array is sorted. Alright, suppose I have taken an array. The name of my array is ARR, and my elements are 1, 3, 5, 7, and 8. So if you will notice that this array is sorted. Suppose if someone asks, hey, tell us the index of 5. That means we have asked you to search the element, sorry, to search the index of element 5. Okay, so in binary search we follow a particular concept, that is the mid value. All right, we have to find the mid value in every traversal. All right, suppose if someone will ask the index of 5. Okay, so as you know, the array is already sorted. All right, so according to you, if someone asks the particular index of 5, you will say him that if the searched element is greater than mid. All right, if that means if the searched element is greater than mid will be start plus end by 2. All right, so if the index 2, that is 1 plus 4 by 2, 1 plus 4 by 2, that is 2. Okay, so second index will contain the mid value. So if your searched element is greater than the mid value, then that means the searched element, or the element for which you are searching, will be present at the right of the mid value, because the array is sorted. And when the searched element is less than the middle value, less than the middle element, then that means the searched element, or the element which you are searching for, is present at left. So the concept is, if the index of an element, sorry, if the value of a particular index is greater than the mid value, then you will find it in the right of the mid value. And if it is less than the mid value, then you will find the element in the left of the mid value. All right, so that's called binary search. All right, oh, let me write a normal code for you. So initially we will take a start variable, which we will initialize with 0, and then we will take a end variable, which will be the last index of our array, and as I have told, the mid value. So the mid value will be start. So if you'll notice, I have taken start, so which part is left? The end part. So for that I'm simply writing a mathematical formula, and minus start by 2. Sorry, my bad. end minus start by 2. All right. So we will use a while loop, and the condition till when the while loop will run will be that start index should be less than or equal to end. It's much self understandable that start index cannot be more than end variable. All right, that means end will always greater than or equal to start. So if your searched element, suppose if your searched element, just a second, if your mid value is less than array of your target. All right, just a second. If the middle value of an array is less than your target element, that means your target element is greater than the middle value. So if the array is shorted and the target value is greater than middle value, then it simply means that you have to search in the right part of the middle value. So I won't do anything. If you notice that the end index will be same, only the thing which will be changed is the start index. Now you won't start from 3 or you won't start from 1, you'll simply start from the right of the middle value, that means middle plus 1. So in this case your start will become middle plus 1. Alright, so the first condition is done, and the second, if the middle value is greater than the target value, that means if the target element, all right, is less than the middle value, that simply means if the array is shorted, then you have to search in the left part of the middle element. All right, so you won't have to change much. The start index will be same. Okay, the thing which will be changed is that now you are searching in the left part of an array. That means your end will be middle minus 1, or you can say your end will be middle minus 1. All right. And what if the middle value is the searched element? You're getting my point. What if you are searching for a value which is already your middle element? So for that case there will be a condition, else if the middle element is equal to the target element, then you will simply return the mid value. Sorry, you simply return the mid value. Or if what if the target element is not present in an array? After the traversal you got to know that you're searching for 4 and 4 is not in your array. So what will be happen? It will simply return -1. So that's the code of binary search, and that's the concept of binary search. In every traversal you will find the mid value, all right, with the reference of two variables called start and end, where we are initializing the start from 0 and end from array dot length -1. That means the last index of an array, and we have taken a variable mid which will return every time, which will return the mid index of an array. All right, so we have taken a while loop. So the condition is start should be always less than or equal to end. That is self understandable that start index cannot be more than the end index. It can be equal but cannot be more than the end index. So in the first condition, where in the first condition the target element is greater than the middle element, so you will search in the right side of an array, so your start will become mid plus 1. And in the second condition, the target element is less than the middle element, so you will search in the left part of an array, so your end will become mid minus 1. And what if your searched element is already your middle element? What if you're searching for 5 and 5 is already your middle element? Then it will simply return the mid value. And if the target element is not present in your array, then it will simply return minus 1. So that's the concept of binary search. Uh, you must be having a question that, yeah, that Nitin Bhaiya, if we have a concept of linear search, then why it is necessary to put binary search in our bucket? So I'm giving you the finest and simplest answer that for linear search we have a time complexity of O of n. That means big O of n. And for binary search, sorry, you know my typo. For binary search, we have a time complexity of big O of log n. It's big O of log n because if you notice, we are dividing the array in half and finding the middle value all the time and applying the conditions for it. So uh, in the next upcoming videos, I'll be discussing the concept of recursion, divide and conquer relationship, recurrence relation. But for now, just remember that binary search uses the divide and conquer relationship. That means you are dividing an array in half and searching for the middle value always. So for that reason, the time complexity of binary search is O of log n. Alright. So what does it mean? It means uh, binary search will take less time in comparatively to linear search. Alright. If linear search takes uh, 5 seconds to execute, and for the same code the binary search will take around 0.1 seconds. So that's the beauty of binary search. So that's the reason uh, we used to study the concept of binary search. But it's up to you, according to the question. If you got to know that there is a restriction of time complexity, that you cannot take the time complexity in big O of n for searching, so that simply means that you have to use binary search. And let me give you two important tricks to find out the question is from binary search or not. First one is that if the array is sorted and it's been asked to search sorry to search for an element, that means use binary search. Alright. And second, if there is a restriction for time complexity, use binary search. So that's all from binary search. I hope uh, this lecture or this topic is much understandable for you. So thank you for giving your valuable time. And if you like this video, if this video comes to be helpful for you, just put a comment. And if you want to suggest me some ideas, or if you want to suggest me some improvement from my side, just put your valuable comments in the comment box. Okay, so till then, take care of yourselves, and happy coding. Thank you.